Hello students, today we will have the new chapter in 12th class, that is the electric potential. Electric potential. First, we would like to know that what is the physical meaning of electric potential. What does it represent? The physical quantity which represents the direction of flow of the charge is called electric potential. Electric potential. The positive charge always flows from higher potential to lower potential. The negative charge always flows from lower potential to higher potential. Thus, the positive and negative charge flow in the opposite direction. Thus, positive and negative charge flow opposite to each other. Just we have studied about the gravitational potential, and we know that the gravitational potential increases as the height of the body increases from the surface. So this is suppose the ground, and then the body is carried away from this one, then its gravitational potential increases. You have seen that the water flowing in the river or drainage, this always goes from higher level to lower level. You have seen the avalanche. When the avalanche takes place, then the many bodies which are placed at the top of the hill suddenly fall towards the ground. So this is the gravitational potential which decides the direction of flow of the nature. And all these rivers and the water flowing in the river that finally meets at the sea or the ocean. Because the sea or ocean, they are always at the lowest level from the ground. We are living at the higher heights. So all the bodies flowing, that is the liquid that always goes from higher level to lower level and finally meets to the sea or the ocean. And you have heard that also the heat flows from higher temperature to lower temperature. So heat is more emitted by the body at the higher temperature to the body in comparison to the body at lower temperature. So the heat flows from high temperature to lower temperature. Similarly, this electric potential is here that always represents the direction of the flow of the charge. The positive charge always flows from higher potential to lower potential, and negative charge flows from lower potential to higher potential. So the positive and negative charge flows in opposite direction of each other. So I am giving you some example of this one. Suppose this is the point A, this is now point B. Suppose this is at potential, this is now your suppose 6 volt, and this is now potential at suppose 2 volt. This is now potential 6 volt, potential 2 volt. So positive charge will flow like this. This is now flow of positive charge. Positive charge, and opposite to this there will be the flow of negative charge. So negative charge flows from lower potential to higher potential, and positive charge flows from higher potential to lower potential. This we have taken the potentials to be the given value. And now suppose we are having, here we are having this point A, this is at 0 potential, and here this is the point B, this is suppose at minus 2 volt. Minus 2 volt is less in comparison to 0 volt. It means that the positive charge will flow in this direction. This is the flow of positive charge. And negative charge will flow like this. This is the flow of negative charge. If suppose we are given the 2 points at the negative potentials, this is now suppose point A, this is now suppose your point B, this is now suppose at your minus 2 volt, and this is suppose your minus 4 volt. Then minus 2 volt is at a higher potential in comparison to this one, and this point B at lower potential in comparison to this potential at the point A. It means that the positive charge will flow from this direction. This is the flow of positive charge, and this is the flow of negative charge. So in this way, if you know about the electric potential at the points, you can find the direction of the flow of the positive charge and the negative charge. So this clarifies you that what is the meaning. This is the physical meaning of the electric potential. Now we take the definition, the mathematical definition of the electric potential. Definition. The electric potential at a point in electric field is defined as the work done in bringing a positive charge from infinity to the point in electric field without accelerating or without change in kinetic energy of the test positive charge. What is the definition? Electric potential at a point in the electric field is defined as the work done in bringing the positive charge from infinity to a point in the electric field without accelerating or without change in kinetic energy of the positive charge. मतलब उसकी क्या है, वेग में कोई परिवर्तन नहीं होना चाहिए तो एक्सेलरेटेड नहीं होगा। इट का मतलब क्या है कि चार्ज पर नेट फोर्स जीरो होना चाहिए। कोई भी चार्ज है, पॉजिटिव चार्ज है, तो उस पर इलेक्ट्रिक फोर्स काम करेगा, बिकॉज इलेक्ट्रिक फील्ड है। तो इलेक्ट्रिक फोर्स इन द डायरेक्शन ऑफ द इलेक्ट्रिक फील्ड, तो इसके अपोजिट हम उस पर फोर्स लगाएंगे। तो सम एक्सटर्नल एजेंसी विल ब्रिंग द चार्ज फ्रॉम इन्फिनिटी to the point in question, so that the force applied by the external agency is equal to the force applied by the electric field. So the net force on the charge is zero. यानी मैं ये कह रहा हूँ कि अगर कोई चार्ज है जिसको हम इन्फिनिटी से किसी पॉइंट तक लेकर के आते हैं, तो कोई एक्सटर्नल एजेंसी उस पर फोर्स लगाएगी तब वो आएगा, क्योंकि उस पर पहले से ही रिपेलिंग फोर्स काम कर रहा है। तो क्या होगा, जितना रिपेलिंग फोर्स काम कर रहा है उतना ही एक्सटर्नल एजेंसी उस पर काम करेगी, तब जाकर के वो चार्ज वहां तक आएगा। तो नेट फोर्स का मान जीरो होना चाहिए। इट मींस देयर शुड बी नो फोर्स ऑन द पॉजिटिव चार्ज। सो इलेक्ट्रिक पोटेंशियल equal to work done upon charge. So this V equal to W upon Q naught. This Q naught, this is called the positive test charge. Q naught, positive test charge. I have told you that in the definition that this is in bringing from infinity. This term is to be understood. At the infinity, no work is done. So the work is there, zero. It means the electric potential there will be zero. So that is the standard position of the charge. So we are bringing the charge from zero potential to some potential at the point in the electric field. It means that whenever we are calculating the electric potential, then we have to take the standard position where the potential is equal to 0. This is why we take this point, this infinity, this the word infinity. Now we can have यूनिट इसकी क्या होगी ना, एक तो इसमें ये जूल पर कूलम, एक तो ये है, एंड सेकंड इज द वोल्ट, V वोल्ट. दिस इज द SI यूनिट एंड दिस इज द ड्राइव यूनिट. Drive unit. So we can have a relation that this 1 volt equal to 1 joule upon 1 coulomb. 1 coulomb. From here we can define the 1 volt electric potential. This is also asked in the many board exams, that define the 1 volt electric potential. If the work done in bringing a unit positive charge from infinity to a point in electric field is 1 joule, then potential electric potential will be 1 volt. If the work done in bringing a unit positive charge from infinity to a point in the electric field is 1 joule, the electric potential will be 1 volt. So now we can have the dimensional formula. Dimensional formula, this V equal to W upon Q naught. This is your M1 L2 T minus 2. This is your A0, sorry, this is your A1 and T1. So we can have this M1 L2 T minus 3 and this is now A minus 1. This is the electric potential. So generally the electric potential of the earth is taken to be 0. It is a scalar quantity and the electric potential of Earth is taken 0, because Earth is very big, it can accumulate a big charge also. So there is no difference if the charge is given to the Earth or taken from the Earth. It means that any amount of charge can be given to the Earth. So this is why that in our houses there is always the earthing. So what that by giving the earthing, there is the flow of the charge. Without that, the current will not flow through it. So this is why that the electric potential of the Earth is taken 0. This is what the electric potential that we have, I have told you here. When a body is charged, then it has the electric potential. So that you have studied in the Gauss law, that the electric field due to a charged sphere, conducting or non-conducting, they have the electric potential. Similarly, charged ring, that also have the electric potential. So all the charged bodies have their own electric potential. So the charge, when the body is charged, the electric potential may be outside to this one, at the surface of this one, and inside to this one. So all the charged bodies have their potential. This is maybe either 0 or this is maybe equal to something else, but it will have the electric potential. All charged bodies have their electric potential. Like charged conducting oblique non-conducting sphere, charged ring, etc. Charged ring, the electric dipole, etc. All they have their own electric field, this the electric potential. So this is what the physical meaning, and that how to find the flow, directional flow of the charge, and the definition of the this electric potential. Thank you.